Okay, Year 13s, in this video we're looking at differentiating the log function. Now there is a proof for this. I'm not going to get into it at this stage, but it is related to the proof of the exponential function. You're more than welcome to have a go at it yourself, but perhaps we might go over it in class as well. But for now, I would like to just stick with this definition, which is the derivative of natural log of x is simply 1 over x. And so I'm going to go through some examples which should illustrate pretty quickly, and then I'll get you to practice some for yourself. Okay, so for the first one, our function that we're given is natural log of 5x, and so our derivative using what we've been given over here is going to be 1 over 5x, but we need to remember to times it by the derivative, which is 5. Okay, so 5x differentiates to 5, and so the 5's are going to cancel out there, and all we're left with is 1 over x. Okay, alright, with question 2, our function is natural log, that's what log e means, of x squared, and so our derivative, f dash of x, is going to be 2x times 1 over x squared. So our x's are going to cancel there, and so this will simplify to 2 over x. Okay, and for our last example here, f of x is given as the natural log of 4x minus 1 to the power of a half. Okay, so we need to be able to evaluate that derivative inside, so I might even just write this as natural log of u, where u equals 4x minus 1 to the half, simply because it's just getting a bit complicated, and this way I can keep track of everything. So the derivative of u is going to be a half times the derivative of the thing inside, which is 4, times 4x minus 1, and then our power is going to be reduced by 1. And so our overall derivative, f dash of x, is going to be 1 over u times this u dash. Okay, so I need to substitute in everything here. So I'm kind of running out of room, so I'll just take this, just grab that and put it elsewhere. Just bring it into some clear space over here. Okay, I just noticed we lost a 1 there. Okay, alright, so let's substitute in now. So 1 over u will just be 1 over 4x minus 1 to the power of a half, and we're timesing it by, well, a half times 4, that's 2, so we're going to have 2 times 4x minus 1 over negative 1 over 2, and that negative 1 over 2 actually means that that brings it down under the bottom of the fraction, and then we've got 1 times 2 on top, so we've got 2 on top of the fraction, and on the bottom we've got 4x minus 1 to the power of a half times 4x minus 1 to the power of a half again. And so when we're timesing things with the same indices, those indices add, and so a half plus a half is a whole, so we've got 4x minus 1 to the power of 1, which is just itself. So that's our final simplified answer. So just be aware that it can get complicated quickly, and that's where the substitution method can become really helpful. But you do need to remember to apply the chain rule at all times, otherwise known as the composite rule at all times, to make sure you avoid making big assumptions there. So just be very careful with those. Alright, so I'd like you to practice on exercise 15.04, and that's where I'll leave this video.